This lesson is on identifying linear functions by tables. So we need to remember that in order to be a linear function, you must have a constant change in your y's and a constant change in your x values. So let's look at this first table. Okay, I look at the x's. I notice from -2 to -1, I'm increasing, and I'm increasing by 1 unit. Then I look from -1 to 0, I'm increasing again, and I'm increasing by 1 unit. 0 to 1, I increase by 1 unit, and 1 to 2, I also increase by 1 unit. So the x values so far have a constant change of 1 unit. Now I'll look at my y values. From -1 to a +2, I'm increasing, and I increase by a +3 units. Then I go from 2 to 5, I notice I'm increasing again, and I'm increasing by 3 again. 5 to 8, I also increase by a +3. 8 to 11, I again am increasing by 3 units. So this one is a linear function because the x's have a constant change by the unit +1, and the y values have a constant change by the unit +3. So this is a linear function. Okay, let's look at another example. Okay, so here's your table. If we start with the x values, I notice that going from -2 to -1, I'm increasing by 1 unit. -1 to 0 by 1 unit, 0 to 1 by 1 unit, and 1 to 2 by 1 unit. Okay, all those have a constant change. Now let's look at the y values. Okay, so from 0 to -3, I actually decreased, and I decreased by 3 units. So I have a decrease by -3. Okay, the next section, I've got -3 to -4. I'm decreasing again because I'm still getting smaller. And I notice here I only decrease by 1 unit. So we already know that it can't be linear because we don't have a constant change. If you were to continue, you would notice that the next set you're increasing this time by 1 unit, and then the last one you're increasing, but you're increasing by 3 units. So because the y values are not a constant change, this is definitely not a linear function. Okay, so this lesson was on identifying linear functions by tables.